Okay, let me see, where's my PowerPoint? Yes, this is the PowerPoint. Okay, so we talk about the function template on Monday. So this is an example or whatever the general syntax for declare a template. So essentially, you provide the keyword template, and then with this smaller than and greater than bracket, and try to put one or more parameter, and over there you declare something we call it some kind of type name. You set type name for TRET. So you essentially write the template looks like this, and then you try to when you use this template, you're essentially doing looks like this. Okay, so because okay, let's actually let me do this. If I have a template looks like this, let me actually use another example to okay, so I'm actually going to give you a using this as an example. If I have a function that this is, I hope my template can actually create a function looks like this. So if this is the case, I want you to right now, if you have a pen or you have a computer, I want you to start writing what should be the template that will create a function looks like this in front of it. I give you about 1 minute for you to think about this. Let me actually copy this piece of code. By the way, all the code I'm using for this template is actually under the GitHub repository 1024-2022. Okay, so I was call it template.cpp. Let me just call it test one CPP. Okay, so my target is to generate a template looks like this. So we're going to write the template. So of course, the first keyword is template, right? Um, sorry. Yeah. All right. And then what should be the next? Let's actually look at the example over here. This is our example over here, right? So what should be the template? Let me actually just keep this one. Sorry, the template syntax looks like this. Okay. Now let's go back. Okay, the first thing to write the template is actually this bracket, that this kind of small than greater than bracket. And inside this bracket, I'm actually going to provide something, and then I'm going to have I would just temporarily call it the type. I call it type of return. And then I'm going to have the name of the template. And then I'm going to have the parameter. And inside the parameter is actually going to here. And then there is a function. Sorry, this is called template function, right? So that is the syntax. Whatever here, I have a bunch of things. Okay, so can any of you start helping me to finish a template that's actually going to generate the function above? Anybody, please speak up. Let's just assume the template is, we call it ecs36b range. Okay, let's just call that as our template, the name of the template. Okay, the first thing is that, well, what should we, where should we start it? Anybody? Oh, okay. Will, please go ahead.
We're going to need to like in the like brackets there say type T because we have
Okay,
one type we need to define. Or
okay.
one type.
Type name, and what should be the, what do you want to call it? Type name, let's call it T whale. Okay, would that be okay? Just one, right?
Yeah.
Well, and then what should be the next? What should be the return type for T well? Is that should be T well as well? No, actually, you
It
need
should
two
also
type.
be
You need
Boolean,
two
right?
type, right? Because you need, the return is Boolean and the argument is double. So at least you need two different type, right? Be able to do that. So let's call this T well. Anybody else will help? Let me actually call it comma type name T Felix. Okay, we have two type. Okay, and then what should we do next? Well, please go ahead.
I have a question about that. Wouldn't it make sense to like for it always to be Boolean? Because I feel like for an is in range function, why would it ever return anything that's not a Boolean? And would it be possible to have one of the types always be defined, or do you always have to have like a return type that's defined?
I think you I actually don't know what's the default, but I believe you always have to have you have to have specified the type for the return. I mean, in my opinion, that for example here, once we have this two type, is going to be T well, and then let me actually put it in the next line. And over here is going to be T Felix. And then I will call this T Felix because it is an argument value. I call the value. Okay, I can actually call it ARG value. And then inside here, I'm going to borrow this piece of code. Okay, then I'm going to do that. Okay, so this is basically our first version. Okay, let me actually write it this way here. So I actually don't know whether this works, but at least try. Hey, Reina, please. Yeah, what
Does the order matter like with inside the bracket?
inside the bracket doesn't matter. Yeah, doesn't matter, and
And
that's
is
a good
this
point. Let's actually try this one.
and then is this just to like or like so this is just for making sure like or we specify like what types we can use inside of or like when we like
Right,
create.
right. When you use it, right? I mean, if I want to use it, so typically when if I call this function, for example, I will say, if is in range, this is the original function. The original function say is a range 10.0, right? Okay, that's basically the function. I will usually do it without the template, but with the template, I'm going to do if ecs36b range. And in this case, the first one is going to be double. and the second one is supposed to be bool. And then 10.0. Okay. So if we declare a template looks like this, then the way to call it is looks like this, because now T Felix is the argument type, and the T will is the return type. Okay. All right. So I don't know whether it works. So in programming, we always try. Yeah, Will, go ahead.
So would you always have to have Boolean as the second one here? Because with the return, it's always going to return a Boolean, right? So you'd always have to call it with Boolean as the second type.
Oh, you're saying that because here the code I said return this, so I have to have this one is always the Boolean. Oh, I see what you're saying, but let me think about this just for a second.
What if you overload the logical AND operator to return
Right.
something other than
Okay.
a Boolean?
No, I understand what he is saying. Okay. So, well, I have a two-way to address your question. Then I forgot. Who is the other person? N, I don't know. N is a Nicholas or something. So so I can actually do this way if the template always return the Boolean. I now understand what you're saying. Okay. Hold on 1 second. Well, sorry, I listen. So yes, you're right. So if it's always Boolean, then I would just put a Boolean there. Yeah. Yes, I can actually, if that is, let me, you know what? We have a different version. I think, Will, I think you're right. In this case, because the code looks like this, so it always return a Boolean. So that should be the way to do it, right? And then if that's the case, over here is just double, looks like this, right? I'm actually thinking there might be situation which I can also templaterize the return type as well. There might be cases, especially in C++, I might have polymorphism. So I might be able to do some kind of more complicated. Yeah. Okay. Is that good for everyone? Let me just keep this here. Let me get rid of this part. Okay, this is just another option. Okay. All right, so let's actually try to run the program. Let me see. All right, what should I do? Include, do I have to include anything? Let me check. Anyway, I will just compile, just let it run, okay? Integer and void. cd cout. True. Okay, it's very simple. std. Okay, let me try to run this. I forgot what I need to include as an include file, but I will just let compiler tell me. S1 CPP. Okay. All right. So apparently I have to include, and you know what? Do I have my ecs36b comment here? Okay, good. I'm actually going to just see. I'm kind of lazy. I will just include my standard. Okay. Okay. Now, okay. it looks like this is okay. So after I run the program, I feel comfortable that this is actually the right way of doing template. Okay. All right. You should do the same whenever you have the situation. Okay. All right. Now we are focusing on this one. Can we actually improve this template even better? The range. Remember when we talk about longitude, latitude, we actually have a, for latitude is minus 90 to plus 90. And longitude is actually minus 180 to 180. So now, yes, the type has been template, but can we also template the range value itself? And the answer is a yes. So anybody try to offer and such that we modify this template and we can actually also template the range as well. Anybody want to raise your hand to do it? Let me see if anybody offered that in the chat. Make a range as argument. Yes, Christopher, you're right. So, okay. So what I'm going to do is provide, I will say over here, I will say integer Chris low. Sorry, let me move this away. Sorry, I cannot be Chris low. Let me actually pick. What should I do? I actually have the answer. Okay, I do have to provide a range. Oh, for the type, I don't like that actually. I thought I have a better way to do that. Unfortunately, I have to say, I'll just say double. Chris low and double. Chris low, Chris high. And then over here, I would say is a smaller than Chris high. And argument is greater than Chris low. Okay, so now you can see that I can parameterize this to be like this. And now when I call it, I'm going to call not just say double, that's the, but assuming that I'm going to use this for longitude, latitude, and then I would say minus 90.0 and high is 90.0. Okay, and do like this. So let's see if this compiler will like it. I have a problem. What did I do wrong? No matching function call. Anybody can debug? What did I do wrong here? Oh, I know. You know, do you know why I did this? I make a mistake. Sorry. This should be right here. Double. Chris low. And double. Chris high. And over here, I need to get rid of this. Sorry, I put it in the wrong place. So that those two is a template argument. I need to provide it over there. And then when I call it, it's immediately replaced by this one, by the compiler. So now, wait a minute. What was this issue? A non-type template parameter cannot have type before. I hate this. Sorry.
Is it because of the version of C++? There it says before C++20.
Yeah, that's actually something. I know if I say integer, it works. No, it's not 20, it's 2K. There is something else is going on. Let me see. Yeah, yeah, it is C++20. That's embarrassing. Okay, no, I'm actually going to look for my original example, which I know it works. Let me actually take a look at my answer. So this is actually good. I mean, oh, sorry, this is your homework 7. Where's my, yeah, this part. This was supposed to work, looks like this. Integer, I know when I did it, it was saying that it's integer, but now it's actually cannot do it for double. So I'm actually going to change this to for integer. I cannot believe that's if I say I cannot do double here. Integer, integer. Sorry, let me get 14.
Oh, you're passing a double value still, I think.
Okay. Yes, the way I call it, right? But the this one, right? This one I have to say minus, sorry, minus 90 and 90 looks like this. I just don't understand why I have a template. I can only parameterize as an integer, not the double. I guess we all learn everything new by testing the compiler. Okay, so now you can see that I can actually parameterize, but I can only parameterize a little bit. I cannot parameterize a double, for example. I can only do that in integer, and I have no idea why it is that way. Okay, so that's actually how we can actually write a function. Looks like this. So good. I think both you guys and me, we both learned a lot of stuff from this one. Okay. All right. Any question for this example before we move on to the next one? Anybody? Okay, good. So I will actually post this code to GitHub in 1024, so you can actually try yourself. Sometimes surprise. Okay. All right. Let me go back to my PowerPoint. All right. All right. So now I'm actually going to tell you the other concept, which I already talked about this a few times, is called pointer to function. So essentially, I have a piece of code, and then I want to really be able to not just pointing at the data, but I will be able to have the address of the function, and then how do we call that? So I want to first very briefly tell you how that's work, and then I want to show you how that can be integrated into the function template as well. Okay. So what is a function pointer? A function pointer, there are two parts. About the first part is how do you actually declare a function pointer? And the second thing is how do you really assign a value? So you declare. So what is a function pointer? What is a pointer? A pointer is an address. And for example, let me actually use this example, and then I will show you what it is. Let me try to copy this piece of code. And I'm actually going to leave this. Do I have the function pointer code already here in the, I thought I have a function pointer here. Okay, but anyway, I lost it. So I'm just writing another one. Function uncptr.cpp. Okay, so if I want to declare pointer to a integer, I would say integer star. This is what I call XYZ. So essentially, I'm saying that XYZ is an address. In fact, the address of the first byte of an integer. Okay, that is how I declare a pointer to a integer. But now I'm trying to pointing to a function. So essentially, what if I do this way here? Then I'm saying fptr. Look at this. I have a bool here, and then I have parentheses, a pair of parentheses with a star with ftr, and then with double. So this is basically say fptr is an address of the first byte of a function, but that function has a prototype. The prototype of the function is that the return type is bool. And it takes one parameter, take one argument, and that argument is the type of that argument is double. Okay, so this is basically only like a less than 20 character, but it contains a lot of information. This one is a declaration, by the way. This is what I call it a function pointer declaration, just like you declare XYZ. And this is basically declare FPTR. So when you look at this, it's actually why it's hard, because you are very familiar with this notation. Is always the last argument or variable, in this case is XYZ, is the variable you're declaring. But in function pointer, it's not. The function pointer, what you declare is actually within the first pair of parentheses and remove the star. So essentially, how do you actually know it's a function pointer? I always, when I see this line, I actually see two pair of parentheses. If you see something with two pair of parentheses, you know it's a function pointer. And then the second thing you need to check is whether the first pair of parentheses, you actually have a star. Because what is a star? Star is a pointer, just like a integer star XYZ, you have a star over here. So by looking at this, you really realize that the blue is the variable you just declare. Okay, and the rest of them is only the type. Especially a lot of time when you first look at this, you actually see, well, what's this part? That part is just saying that it's a type of the function. It's a function prototype that you try to pointing to. Okay. All right. Any questions so far? Okay. So for example, previously let's actually go back to the other function. And I have this function here. I'm actually going to borrow this function again. So I actually have a function declare is in range. And is in range. If you look at the function prototype, let me control X1. So if you look at the function prototype of is in range, the function prototype, the return type match with the declaration of function pointer, and the argument type and argument count also match with this. So essentially what I'm saying is the function prototype for this function is in range match type to type with the FPTR we just defined. And therefore, it's actually okay for you to just assign the value to say FPTR is equal to is in range. Okay, so that's the way how you assign. So this part is just declare the pointer. This part is I really assign the address, because what is, so this is actually something you might not realize. When you actually declare a function that is in range or ecs36b range, when you declare that, the function need to be placed in the memory. So it has a memory address, and the pointer basically refer to the first byte. It always the first byte of the code. That's actually the entry point of that function. So therefore, you can actually do this. This is basically a sign. So once you actually do this, so basically this pointer fptr is pointing at this function, just pretty much like it's pointing at this object or pointing at this variable, okay? And now the final part is, well, how do I actually call it? How do I actually really call this function? You actually just call it this way. You basically take a fptr, you dereference and put another pair of parentheses, and then you actually put the whatever the argument. So essentially, if you see two pair of parentheses back to back with each other, you know that's either a declaration of function pointer, or in this case, you're actually really calling that function pointer. Okay, so in this case, I'm actually just call it because I dereference that pointer, and then I actually provide the parameter, and that's it. Okay. Any question? Yeah, I saw a few questions in chat. Okay. Hey, James, I missed your question. I think that will be interesting. Can you have a type argument to T Felix? I will actually I will try that a bit later myself. I never tried that, so I don't know whether it will work. And Reina, yes, is in range is the name of the function, but in the program, yes, it is. It is the address of that function as well. So the name of the function is address of the function. Hey, Nicholas, yes.
So could we call f pointer without the star, without dereferencing it? Because if f pointer is type equivalent to is in range, and we just call a function normally by using by just typing the name of the function, what if we just do fptr in parentheses 2.0 instead of first dereferencing it?
Yeah, I understand what you're saying. My instinct said no, you have to have that, but I sometimes have doubt to my instinct. So let's try to run the program. Okay, let's try to compile this program and see how it works. Okay, let's do this. Let me make it a just global variable. That's fine. I can do this. Okay, I put in my favorite file. Include that I have this. Let me actually copy this part over here. And I have a integer main void. Let's see how it works. Okay, and return 0. And over here, I'm going to do std cout. True. I'm just lazy. True \n. Okay, it's easy. All right, so let's actually try to run the first version, and then we're going to try the what Nicholas suggests. G++ minus std is equal to C++ 14 down pointer. Okay, at least the compiler is okay, so it's okay. All right, let's actually try the other way. So this is what you suggest, right? Or maybe we just do this way, right?
Yeah.
Okay, let's try to see whether it allow me to do that. Oh, it works actually. Good. Okay. See, Nicholas, that's good that you have that good. Let me try the other thing. If I do this, would that work? Yeah, either way works. Then why do I put a star there? I don't understand. Yeah, I probably somehow I got the impression I have to do that in order to get it work. And I'm so narrow, I believe anybody different from that must be wrong. So so that's why, yes, that's great. We have 3 options. Apparently our compiler is actually very open mind about all kind of possibility. That's great. So this one is good. And this one is okay. And also this one is okay too. So any of this will work. Huh. Then I just wonder, can I actually declare this way? Can I declare this way? No, I cannot declare. Wait a minute. Yeah, that I don't know. Okay, that is, it looks like when I declare, I have to do it this way. Okay, anyway. All right. Okay, that's good. So you probably see this is how you can declare. It looks like when you declare, you have to do it this way. And then this is an assignment. You can actually assign a function to the function pointer. And then when you actually try to use it, you can actually have a 3 different way. We actually just show you that any of the ways seems to be acceptable to the compiler. And that's great. Okay, so I'm going to comment 2 of them out and just tell you that you can use 1. Okay. All right, any question? Any other question about function pointer? All right. Let's move to the next topic.
Oh, I put some questions in the chat.
Sure, go ahead.
I had 2 questions. It's like, or I guess, what are the benefits of using function pointer instead of just like, or like, why should we create like a new variable having the function pointer when we can just use the function?
Right. Okay. So you know what? Let's actually take a look at this piece of code. So the question is, why do I bother to using a variable, right? Because FPTR is a variable. Why is not just calling it with a variable? Okay, so I think this is a great question. We always want to ask, why do we want to have this? It's just like I always ask, why do we need the multiple inheritance, right? So I want to solicit your opinion from the class. So what do you think? Why function pointer is valuable or useful?
I have one idea.
Okay, Nicholas, go ahead.
Okay, so I recall a few classes ago you were defining a handler for catching the I think it was the segmentation fault sig-seg-b. So in that case, it would be useful to be able to treat a function as if it were a variable. So like you can pass the function as like a handler. So it's like a piece of code. It's a subroutine that you can sort of run to catch that segmentation fault. But like you use the struct for it, if I recall correctly. So it's like you can. It's easier to pass around functions.
Okay, that's a good thought. It's always provide a flexibility and dynamics. Because why? Because we sometimes want a function to have a polymorphism, to actually be able to be configured differently when you try to call the function. So therefore, at the compiler time, I might not know which function I really need to call at that moment. So think about this. This is actually has to do with polymorphism, has to do with the function pointer, and also a very important concept. This actually I realized. To be honest with you, I know this difference exists, but until this quarter, I realized that this difference is so important. The regarding compiler time and runtime. So, for example, segmentation fault is completely a runtime concept. It's nothing to do with compiler, because from the compiler perspective, I actually don't know whether it's a segmentation fault. It's depending on when I hit the operating system. And that's why I can use that whatever offset when you do your homework assignment number 5. I have that offset. That was because that was actually the offset was determined at the compiler time, at the runtime. And similarly for polymorphism, polymorphism is actually I call a piece of code, but the compiler really don't know what that code really is. I have to wait until runtime to actually be able to catch it. And therefore, because that mechanism cannot be handled by the compiler time, so it's at runtime, I'm going to set the value of the function pointer and then try to call it. So essentially, if I only look at this lines of code, and in fact, I have no way to know which function is actually going to get called, because that particular function may be determined at the runtime. So therefore, function pointer really help us to determine something. We can say it provides flexibility, but it really provide a handle so we can actually be able to determine the behavior, the exact behavior of the function at runtime. Okay, so that is why the most common way about thinking about function pointer. And by the way, there is a concept you can actually take a look. For all of you interested, this is called dynamic linking library. So the thing is that we know that when the compiler, the last stage of the compiler is trying to linking different library together. And there's two ways. The first generation of a library is all static. So it means that at the time you link, you already know what the code you're going to call. But with dynamic linking library, meaning that you actually can replace the code. So for example, you actually already have a code running for 2 years. And now I actually create another piece of code is from the format of the dynamic link library. And I can dynamically link that to your current code. And then it's going to have a new behavior because I'm actually let it run to the different part. Okay, so that is why sometimes function pointer is useful in those cases. Okay, any question? All right, I'm actually going through very quick another example, then I'm going to switch to office hour mode, okay? All right, so this is an example we just actually see, but I want to show you a more interesting example looks like this. Yeah, okay, so this is an example, kind of combine function pointer and the template together. Okay, you can see that I'm actually creating, this is the template we already have. Oh, integer, great. And then I declare a function pointer. Declare a function pointer looks like this. And I can actually declare a function pointer as the result of the template because it's in range, whatever this is actually going to be instantiate a function from the function template. And then I can put it into the function pointer, and then I can just basically create this. I can just call it. And also I have a one line of code. I can actually print the value of func pointer, which is the address, which actually tell me that where this code was actually being located in my memory. Okay, so that having said that, I'm going to conclude the lecture part for today. I'm going to, you know what, I'm actually going to